Okay, so this is Algebra 1, Semester 2, Chapter 8, Section 8283. So A2 deals with multiplying and factoring algebraic terms. So the first section deals with multiplying a monomial and in this case a trinomial. So a monomial is one term algebraic expression, while a trinomial is a three-term algebraic expression. So for got it number 1, we have 5n times 3n cubed minus n squared plus 8. So everything inside of the parentheses is being multiplied by everything outside the parentheses. So in this case we have 5n multiply 3n cubed minus 5n times n squared plus 5n times 8. 5 times 5 is 15. N times n cubed is n to the fourth. I just add their exponents. Negative 5, remember there's a 1 in front of that n squared. So negative 5 times 1 is negative 5. N times n squared is n to the third. 5 times 8 is 40. And then n times 1 is n to the 1. So this is using the distributive property. We multiply 5n times everything inside. The minus sign goes down, the plus sign goes down, and we multiply those three terms individually by 5n, and that gives us 15n to the fourth minus 5n cubed plus 4n. Again, that's using the distributive property. And for problem 2, they are talking about finding the greatest common factor between terms. So the greatest common factor is basically the number that you can divide out, that all terms that you're trying to find, or in this case the common terms that you're trying to find between each terms, you can factor out or divide out. So I'm actually going to do the example and then go through the problem. So for the example, they have 5x they have 5x damn it they have 5x cubed, they have 25x squared, and then they have 45x. Alright, so then they try to find the primes of each one. So basically they do the factor tree. So if we look at the 5x cubed, they try to break it down into their primes. So 5 is already a prime number. You can't break that down any further. The x cubed, since there's 3 x's, you can break them out in 3 different ways. That's the way to divide the variable, where you can't divide it any further. So I have 3 x's, and then these are all being multiplied by each other. That's the first factor tree. Then we have 25x squared. I could break down 25 into 5 times 5, and then I can't break it down any further. I could break down the x squared into x times x, and then I can't break that down any further. And then 45x, I can break the 45 into 9 times 5. Then I can break that up into 3 times 3, and I can't break that up any further, and then I can break out the x to just x. So when I try to find the greatest common factor, I gotta find the biggest number that all three of these terms share. Well, they share a 5, a 5, and a 5. They can also share 1x, 1x, and 1x. They can't share any other x's because this term here only has 1x, and that's all you can take out. So usually it's going to be the smallest degree of these variables. So since there's only x to the first power here, that's the only thing that I can factor out. There aren't any other 5s. There's a 5, there's no 5 here, other 5, there's no other 5 here, there's no other 5 that I can factor out. And then this is the only term that has a 3. No 3, no 3. So the greatest common factor for these three terms is 5x. And that's the greatest number that I can pull out or factor out between all of these. So you don't necessarily have to do the factor tree every single time to do this. You can actually sort of do it mentally. Using the factor tree was just sort of to show you where it came from and how to set up to pulling it out. Looking here and trying to find the greatest common factor, I see 3, 9, and 12. I can pull out the 3. 3 divided by 3 is 1, 9 divided by 3 is 3, 12 divided by 3 is 4, and I can pull all of that out. So 3 is one of the factors. And again, I'm using mental math here, and you can use mental math here in these types of problems. X, there's only one x here, so I can't pull out 2, I can't pull out 4, I can only pull out really the smallest of the variables. And since there's only x here, I can pull that out. They all share the x. I say that the greatest common factor is 3x. Why do I want to know what greatest common factors are? Because I can factor out greatest common factors by trie and polynomials. So for got it 3a, they want me to factor out 9x to the 6 plus 15x to the 4 plus 12x squared. Okay, so I look at these, and in terms of the greatest common factor, I can definitely pull out a 3 here. 3, 9 divided by 3 is 3, 15 divided by 3 is 5, 12 divided by 3 is 4. The smallest term here is the x squared. This can pull out an x squared, this can pull out an x squared, this can pull out an x squared. So in this case, the greatest common factor is x squared. So when I factor this out, in my mind, I divide. So I have my 3x squared. I know that 9 divided by 3 is 3. So this is going to be 3. X to the 6 divided by x squared is x to the 4. Remember, I just subtract the exponents. X to the 15 divided by 3. Or I'm sorry, 15 divided by 3 is 5. X to the 4th divided by x squared is x squared. And 12 divided by 3 is 4. And x to the square divided by x to the square is 1, or I just leave it alone. And this is the factored out form. I just factored it out. And if you want to check to see that it works, you can do the distributive property and see if you get the original term. So 3x squared times 3x to the fourth gives me 9x to the sixth. 3x to the squared times 5x squared gives me 15x to the 4. And then 3x squared times 4 gives me 12x squared. So it works. So this is the factored form of that particular trinomial. Okay, so that's the 8-2. And then 8-3 deals with multiplying binomials. So basically this is the section on FOIL. The book gives you 3 different ways to multiply binomials. I'm going to talk about 2. You can use the distributive property or you can use FOIL. I'm not a big fan of the box prop. It's good, but it's a little cumbersome. And you get the same amount doing the distributive property of FOIL. And I think those two are better and superior. So we have x minus 6, this is got it 1a, or 1, times 4x plus 3. So this is using the distributive property method. So what I can do is I can either pick the 4x plus 3 or the x minus 6, it doesn't matter which one. And I can use the distributive property individually. So I can say, okay, I'm going to use the x minus 6. I'm going to say that x minus 6 is x, and I'm going to multiply that x times the 4x plus 3, right? Then I have the minus sign right here. Actually, I'm just going to call it minus 6. Minus 6, and I'm going to multiply that minus 6 also times 4x plus 3. So basically I'm using the distributive property. I'm splitting up the first term, or the first expression, to its basic parts, x here, negative 6 here, and I'm multiplying the 4x separately from those terms. So I have x times 4, x times 3, which is x times 4, which is 4x. X times 3 is 3x. Then I have this negative 6. Negative 6 times 4x is negative 24x. Negative 6 times 3 is negative 18. Alright, once I get to this point, then I combine like terms. So 4 has x raised to the first power, 3 has x raised to the first power, and negative 24 has x raised to the first power. So these are all like terms, so I can combine these guys. 4x plus 3x is 12x. And then negative 24 plus 12 is negative 12x. And that's it. I'm done. I can't combine it any further. So x minus 6 times 4x plus 3 is negative 12x minus 18. And that's using the distributive property. I separated them individually and I multiplied them, the terms, by those separated out figures. Now, that's one way of doing it. The book also suggests the box thing and putting or the table method. I'm not a big fan. And then there's the other way, and that is, and the more common way, is using FOIL. FOIL stands for first, outer, inner, and last. So the example that the book gives here is 5x minus 3 times 2x plus 1. The first means, I'm just going to write it out, 5x 3 2x plus 1. So the first just means that, so let's call this the first term and the second term. We can also call this the first term and the second term. So since this is the first term of this guy, and this is the first term of this guy, I can multiply them. So first, for the first part of FOIL, so FOIL stands for first. So the first term of this guy is 5x times 2x. I'm not going to do the math, I'm just going to get into what the FOIL means. Then we have outer. In addition to this being the first term, we can also think of this as the outside term. This is on the outside of these four numbers. This is on the outside. This guy is also on the outside. So then I can multiply the outside terms. So 5x times 1. That's the outer terms or the outside terms. Then I have the inner terms. So this would be inner. This would also be inner, because they're in the inside, right? So these are the outsides, then these guys must be the insides. And that's going to be negative 3 times 2x. And then we have last. So if this is the first, then this would be considered the second or the last. So that would be my last. This would also be my last. And I can multiply these guys. And that's going to be negative 3 times 1. First, inner, outer, inner, last. FOIL. So they give us 3 examples to use FOIL. We have 3x minus 4 times x plus 2. So 3x times x is, and I'm doing this mentally, 4x squared. Then outer, which would be 3x times 2, which is 6x. Then we have inner, negative 4x times x, which is negative 4x. And then we have last, which is 3x times 2, which is 6x. I look for, whoops, my brain is not working. Last is 4 times 2, my bad, which is 8. Okay, so 3x times x, which is 4x squared, 3x times 2, which is 6x, negative 4 times x, which is negative 4x, and then negative 4 times positive 8, which is negative 8. Okay. Combine like terms. The only like terms that I see here is the 4x and the negative 4. I mean the 6x and the negative 4x. So I combine those guys. 6 minus 4 is 2. So then 6x minus 4x is 2x. I can't combine it any further. So my final answer is 4x squared plus 2x minus 8. And that's A. B. We have n minus 6 times 4n minus 7. So n times 4n is 4n squared. That's the first. The outside is n times negative 7. So n times negative 7 is negative 7n. Inside, inner, negative 6 times 4 is negative 24n is negative 24n, and then last 6 times negative 7 is positive 42. Combine like terms. These are the two guys that are the same variable raised to the same power, so I can combine them. So it's going to be 4n squared. Negative 7 minus 24, they're the same sign, so I add the absolutes, so that's going to give me negative 31. It's going to be negative 31n plus 42, and then I'm done. Yeah. FOIL again, first, outer, inner, last, so 2p cubed times 2p is 4p to the fourth power. 2p cubed times negative 5 is negative 10. P cubed, 3p times 2p is 6p, and 3 times negative 5 is minus 15. There aren't any like terms to combine. This is p to the third power, this is p, so they're not the same. Therefore, it's already simplified. So I am done. Alright, so this last one involves multiplying, but using some geometric terms. So in this case, they give me that I have a surface area of, they want me to find the surface area of a cylinder. So the surface area, if you recall, which you might not remember from way back when, is 2 pi times the radius. So that would be squared. So that's the area of the first circle and the area of the second circle. So we're adding those two areas together, plus the area of the middle part of the cylinder, which is the circumference of the cylinder times the height. So the circumference is 2 pi r of a circle, and that's going to be times the height. Okay, so for a cylinder like this, just again to refresh your memory, radius is the distance from the center of the circle out. So in this case, the radius is x plus 1. The height is going to be the distance that connects the two circles together. So this here is the height, and that would be x plus 4. But in this case, we're going to use the dotted number 4, and they tell me that the radius is equal to x plus 2, and they're telling me that the height is equal to x plus 4. So with that information, they want me to find the surface area. Okay, so let's attack these separately. And we could look at the 2 pi r squared part. So we know that it's 2 pi r squared, but now we know that r equals x plus 2. It's going to be 2 pi x plus 2 squared, which is the same thing as saying 2 pi x plus 2 times x plus 2. Right? So that means that we're going to use FOIL. So x times x plus x is x squared. X times x rather. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Then I'm going to combine like terms, and that's going to give me 2 pi x squared plus 4x plus 4. So this is my height. This would be my height. Oh no, didn't mean to do that. Well, you know what that means. Let's see, I can remember stuff. So my height was 2 pi x squared plus 4x plus 4. Okay, that's my height. Alright, so the other part of the surface area, oh no, I'm sorry, that was the area. Alright, so the other part of it was the circumference part, the 2 pi RH. So 2 pi RH, we were told that R equals x plus 2. And then the h equals x plus 4. Okay. So that's going to be 2 pi x plus 2 times x plus 4. So again, FOIL, x times x is x squared. Outside, x times 4 is 4x. Enter. 2 times x is 2x. Last, 2 times 4 is 8. Combine like terms, and I have 2 pi x squared plus 6x plus 8. So that's the 2 pi h. So then when I put these together, the whole surface area is going to be 2 pi x squared plus 4x plus 4 plus 2 pi x squared plus 6x plus 8. Notice something. Both of these guys are being multiplied by 2 pi, so I can factor that out from both expressions and then combine these two guys in the middle and at the end. So I'm going to factor out the 2x, 2 pi rather. I'm going to factor out the 2 pi, and that's going to give me x squared plus 4x plus 4 plus x squared plus 6x plus 8. So I factored out the 2 because they're both being multiplied by 2 pi. I factored out the 2 pi, and I can add these two guys together in the parentheses. Then I can combine like terms. 4x plus 6x, I can combine those guys. I can do x squared and x squared, and I can do 4 and 8. I can add all those guys together. I can combine them. So it would be 2 pi x squared plus x squared. I'm going to move them around using the commutative property. Plus 4x plus 6x, and then plus 4 plus 8. And then I'm add them up. So then my final answer is going to be 2 pi x squared plus x squared is 2x squared. 4 plus 6 is 10, so then 4x plus 6x is 10x, and then 4 and 8 is 12. So then my surface area is going to be 2 pi times the sum of 2x squared plus 10x plus 12. So basically we used FOIL twice, and then we combined everything together. We were told that the surface area is 2 pi r squared plus plus 2 pi r h. Used FOIL, expanded it out, then we were able to factor out the 2 pi, and then we combine like terms inside the parentheses to get 2 pi times 2x squared plus 10x plus 12. And that is it for surface area. The last thing that we're going to do is multiply a binomial by a trinomial. So all you have to do, well, the book is doing the vertical method. You can do the vertical method, that's fine. I don't do the vertical method, I do the horizontal method. So so they have x minus 3 times 2x squared minus 3x plus 1. I use the distributive property. And I say that I can multiply everything inside by everything outside. So for the first part, I can multiply x times the 2x squared, x times the negative 3x, and then x times the 1. So it's going to be x times 2x minus x times 3x plus x times 1, right? Then I can do negative 3 times 2x squared. Oh, that was squared. Yeah, but that's kind of important, isn't it? Alright. Negative 3 times 3x, which is positive, so plus 3 times 3x, and then negative 3 times 1, which is minus 1, minus 3, or 3 times 1. So I do the horizontal method, and I use the distributive property. You can do the vertical method. I'm not a big fan of it. I think it takes a lot of space to do. This takes less space. Both ways you can sort of get a little lost. But I am a proponent of the horizontal method. Then the next step is to multiply these guys. So I have x times 2x squared, which is 2x cubed, minus x times 3x, which is 3x squared. And doing it this way, you can end up doing it easier for mental math. Like I would do a lot of this in my brain as opposed to writing all of this out. As you get better at doing these, x times 1, which is x, negative 3x squared, or negative 3 times 2x squared is negative 6x squared. 3 times 3x is 9x. And negative 3 times 1 is negative 3. Then I look for like terms. So I see an x squared and an x squared. That's a like term. I see an x and an x. I can combine those guys. So if I was to rename it, it'd be 2x cubed minus 3x squared minus 6x squared plus x plus 9x minus 3. If you need to see it better and rename it, feel free. If you can do it from here, that's fine too, and use mental math. 2x cubed is by itself. There's nobody to combine it with. Negative 3x, or negative 3 minus 6 is negative 9, so negative 3x squared minus 6x squared is negative 9x squared. X plus 9x is 10x. And then 3 is by itself, negative 3. I can't combine it any further, so I am done. So I have 2x cubed minus 9x squared plus 10 minus 3. I used the horizontal method. I then distributive property. I multiplied the x across the parentheses, then I multiplied the negative 3 across the parentheses. Then I looked for like terms and I combined them and then finally simplified them. That's funny too. Look at the reasoning. How can you use the distributive property to find the product of it? So they even hint that you can do it, but they don't show you an example when I said do vertical method. Really though, interesting. Okay, so that's 8-3. And that's it. We're done for today. I hope you have an excellent rest of your day.